Hello, everyone, and welcome to this second session in our series for the summer of 2023, Leading in Extraordinary Times, sponsored by the International Institute for Knowledge and Innovation. This second session, I'll introduce you to our speaker in a minute. Last week, we kind of set the stage. We'll be going through 6 sessions starting today, each focusing on a particular aspect of leadership needed for these extraordinary times. And we talked about how we kind of defined those extraordinary times last week. And it's remarkable when you see right now, at this point in time, we're able to see out to the edges of the universe. We're able to see things that happened over 13 billion years ago, just a few 100 million years after the universe was formed. And we're on the other end, we're able to dive deep into the discovering new subatomic particles. And so the range of information that is now available to us and knowledge is literally exploding. And so our 6 types of leadership, it's appropriate that we start today's session, the first of the 6, on science-based leadership. Because if you don't have given all the capability we have today with our science, if you don't ground what you're aiming for, as we'll see next week, there's strategy, and then the following weeks, the processes and methods for leading and adapting to all the changes. If you don't start with science, you're very likely to go off on a wrong path. And so it's very appropriate then we have for our speaker today a well-recognized, world-renowned scientist. He has spent over 30 years prior to his retirement at the National Institutes of Health. He was a scientist there, a chief scientist, senior executive. He was the first deputy director of NIH's Institute for Arthritis and Musculoskeletal and Skin Diseases. He is a specialist in immunogenetics and transplantation biology. And since his retirement, his passion for science has not ended, but has kind of shifted a bit. And his current passion now is as you'll hear from him, is with climate science. And of course, that is clearly a major driver of what's going to be impacting us for the foreseeable future. So with that, I'd like to introduce our speaker, Dr. Stephen Hausman, with his presentation, "The Storm is Here, Consequences of Climate Change." Take it away, Steve.
Thank you very much, Art. I'm going to share my screen now, and you should all be able to see what's happening. So this is being produced by the International Institute for Knowledge and Innovation. And I guess one question to ask, and you sort of addressed it, Art, is why are we discussing climate change in an educational series on leadership in extraordinary times? I mean, why should we be doing that? And the answer is, it's one hallmark of a leader to be able to deal with a series of crises and threats that are encountered. And climate change, I would suggest, is one of the most serious existential threats faced by humanity. Leaders must be able to understand and learn about these threats and deal with them. Now, military leaders go to military academies and the War College, and CEOs and COOs go to business schools, and climate scientists go to graduate schools. So what do people who do not have science background do? Well, they attend presentations like this. So what is climate change? Well, it refers to long-term shifts in weather patterns. Weather is short-term, this week, next week, but climate is long-term, over years, decades, and even centuries to determine what's happening. So it could be natural, based on things like variations in the solar cycle. It could be driven by human activity, such as we encounter now, burning fossil fuels. Burning fossil fuels, it turns out, generates greenhouse gas emissions, and they act like a blanket that's wrapped around the Earth, and it traps the sun's heat, raises temperatures. It prevents heat from radiating back out into the outer space, which has happened previously. And those greenhouse gases are carbon dioxide and methane, and also nitrous oxide. Nitrous oxide a lot of people are not familiar with, but it comes from agriculture, fuels, and waste materials. So I have a question. Do you feel that you have been personally affected by climate change? And you can use the chat box for responses. And Art, if you see a few things coming up, just let me know what's there, and we can see what people are saying. Now, it could be things like you've been affected by a drought in your area, if you're in California, or a wildfire, or you have been, not able to go on vacation because of a hurricane that had an impact on where you were going. Well, don't see anything coming, so we'll go right ahead. Okay.
Yeah, and by the way, I did not mention at the beginning. Please, these sessions are meant to be interactive. So as you come up with thoughts, ideas, questions, and as well as answering questions that the speaker poses, please feel free to join us. Let's make this interactive. So Candace, yes, thank you. She mentions impact from drought, heat, unusual rains, that sort of thing. So everybody, please feel free to chime in and also ask your questions as we go along. Thanks.
Great. So what you see on the screen now is a publication by the American Association of Actuaries, talking about the IPCC climate change report. Now, why did I bring this up? Well, if you want to know whether climate change is real or not, you have to go to authorities. And the authorities that I go to are actuaries. They're professionals who specialize in accessing and managing financial risk. And they're totally independent, and they're data-driven, and they're nonpartisan. So you can get a really good assessment of whether something is real or not. And in the report, there's a quote that says, "It is indisputable that human activities are causing climate change. Human influence is making extreme climate events, including heat waves, heavy rainfall, and droughts, more severe and more frequent." And that's correct, as we can see what's happened in California last year. So let's go back into history a bit. Greenhouse gas concentrations now are at their highest levels in 2 million years. And this is based upon analysis of ice cores, ocean sediments, sedimentary rocks that can be done. So the Earth is about 1.1 degrees centigrade warmer than it was in the late 1800s. 1800s are about roughly 1880 is when it's considered to be the beginning of the second industrial revolution, when there was a transition from water power, wood and charcoal to coal and eventually fossil fuels. It turns out that a lot of the things in the United Kingdom that were powered by water ended up having to switch because there were droughts that lessened the ability to have water-powered devices. Okay, this last decade was the warmest decade on record, and the current decade is getting ready to exceed that. So this is what carbon dioxide in the atmosphere looks like. This is the Mauna Loa Observatory in Hawaii in the Middle Pacific. That's considered to be the area that has really the purest air on Earth on an average basis. And you can see going from 1960 up to 2020 that it's been a total trend line all the way up. Now, certainly there are variations in season, but by and large, the trend line is up and it has not shown any variation. Okay, this is the trend of carbon dioxide for the last 800,000 years, as I said, being done by ice cores and other methods. And you can see that the atmospheric carbon dioxide level, which has never really been above this level, is now up here, the highest level ever recorded in 800,000 years. Now, this is produced by the NASA people who are involved with climate. So what are the consequences? Well, the consequences are things like intense droughts, water scarcity, severe fires, the wildfires in California, rising sea levels, flooding, melting polar ice, catastrophic storms, and declining biodiversity. In fact, I heard on the news this morning that one of the strongest cyclones, that's what they call hurricanes in the Pacific, is now on Guam with at least 140-mile-an-hour winds. It was going to take a direct hit on Guam. So we're encountering it even daily. There will be effects on health, the ability to grow food, very difficult if there's a drought, housing issues, people get flooded out, safety and work changes, sea level rise, and saltwater intrusion have caused some communities to have to relocate. And I'll be talking a little bit about internal migration. Droughts, of course, put people at risk of famine, and climate refugees will continue to rise, not only a little bit in the United States, but around the world to a great extent. This is a trend line for greenhouse gases in general, showing that's been going up since 1980, pretty much a straight line. This is separating all those: carbon dioxide, nitrous oxide, methane, and various chlorinated fluorocarbons. Now, it's interesting to note that since about 1995, the level of chlorinated fluorocarbons has dropped. And the reason is, these are Freon used in air conditioners. The reason is that there was a ban on producing any more of these and installing them in air conditioning units. So if you have an air conditioning unit that's fairly old and you need Freon, and you can get it, it's going to be very expensive. But over time, gradually, if no more is being added to the atmosphere, the level will decrease. And that's a good thing to know. Here's a trend line going over the past 2,000 years, again, for carbon dioxide, methane, nitrous oxide. And it's been pretty level, you can see. But then when it reaches around 2000, it goes up in all these cases. Important trend is the amount of mass ice in glaciers. And that has been going down since 1970, rather precipitously, as you can see. Global sea level has been rising. Again, 1880 up until the present, around 2020, it's been just going straight up. Now, it's interesting to know that, and some people say, well, the warming is simply due to increased heat coming from the sun. That turns out not to be the case. If you look at 1600 to 22,000, it's been relatively constant, except for this arrow, which is called the Maunder minimum. And that was a time when there were very few sunspots, maybe 8 or 9 sunspots per year, versus the normal 90 to 100. And that coincided with what is called a little ice age in the northern hemisphere. And Viking settlers abandoned Greenland for this, and Norwegian farmers demanded that the Danish king compensate them for lands occupied by advancing glaciers. Is it possible to happen again? Yes, it might, but it also might be compensated for by the increased carbon dioxide in the atmosphere, which would end up causing more heat retention. Again, the ocean heat content, going from 1960 to 2020, you can see that the heat content has gone up precipitously. Now, there's a lot of heat being produced. It turns out the oceans are where most of the heat is being stored. Once you heat up water, it takes a fair amount of energy to heat it up, but it stays there for a very long time. So this video will show the average temperature in the global temperature range. The blue and white lines are cooler, the red and orange lines will be warmer. And you can see it's been roughly fairly cool from 1880 to the 20s. But as you get to the 1920s, 1930s, you begin to see a little bit increase in the red and orange lines. And as we get into the 1950s and later on, and certainly when we get to the 2000 area, the orange and red lines increase significantly. And this means it's coming out to a temperature, as you can see here, of roughly 1 degree centigrade, and even beyond that to get up to the 1.1 degree increase. Now this will shift a little bit, and you can see graphically what it looks like. Fairly striking. This was also produced by NASA in their Climate Visualization Center. So what's the impact of the increased temperature on the environment? Well, it turns out that if you add heat and moisture to the air, you get extreme weather. Weather can be normally extreme at times, but even more heat means more energy that powers even more extreme storms. You listen to the broadcasters talking about hurricanes, and they talk about energy increasing the amount of wind and so forth in hurricanes. That's due to heating in the ocean. And warmer air can also hold more moisture, so that plants and soil lose moisture to the air. That means more drying, more frequent intense droughts, and a higher risk of wildfires. Storms are able to drop much more precipitation because the air holds much more water. And there's also a loss of Arctic sea ice due to the temperature. And so what's the impact of temperature on the weather? Well, we have certain fundamental atmospheric circulation patterns, like the jet stream. And the loss of Arctic sea ice affects these patterns. Okay, the jet stream is driven by the temperature differential between the poles and the equator. That is, the poles are cold and the equator is hot. So if you have a lower differential, and that's due to the warming Arctic, it leads to a slower jet stream. If the jet stream slows down, it tends to develop loops that remain stuck in place for long periods of time. And that means that you get longer, intense, more heat waves, droughts, flooding events, and cold snaps. This little video shows some of that.
Plagued France, Italy, Spain, and Portugal for weeks. And rivers on the continent are drying up.
The Yangtze has been reduced to puddles, with dozens of its tributaries drying up. This is the result of a record-breaking drought.
In fact, it's hard to find examples of major weather events from last year that aren't connected to the changes in the jet stream.
The Texas deep freeze was caused by the jet stream becoming so wavy that it brought Arctic air from the poles to the southern U.S. Later, the jet stream was so coiled and slow over the Pacific Northwest that it trapped a high-pressure system over that region, allowing hot summer sun to heat stagnant air to new highs.
The severe heat wave that struck the Pacific Northwest last summer, that was one of these huge northward swings in the jet stream.
It's a 1 in 1,000 year event.
It cuts off and forms an eddy, like in a river when you have a swirl along the side of the main stream that just sits there.
Then Hurricane Ida slowed as it hit the Gulf states, and instead of being pushed offshore by atmospheric winds, it was blocked by a high pressure system and dropped record rain over the eastern U.S.
As the North Pole and the polar regions warm in general, there's less of a temperature variation between the polar regions and the mid-latitudes. And what that means is the jet stream slows down, becomes wavier, and that wavy pattern takes the coldest air and actually pushes it south down into the mid-latitudes. That is why we're seeing this kind of cold.
Those strong changes that we're seeing in the Arctic, that's resulting in the wavy jet stream pattern and more of these polar air outbreaks.
And that's drilling down some chilly air, so it will be pretty chilly around here, believe it or not.
And that's what happened in the weather. So what's really the big deal about a temperature increase? I mean, they're talking about limiting temperature increase to 1.5 degrees centigrade. Is a 2 degree centigrade increase really worse? And the answer is yes, it is. It turns out that the number of people who experience severe heat waves at 1.5 degrees centigrade increase, or 2.7 degrees Fahrenheit, is much greater at 2 degrees centigrade. You can see this in terms of the number of circles, which is 1% of the global population. So as the Earth gets warmer, then severe heat experiences and heat waves will become much more common. This is something called the conversation. They estimate that there were 2 trillion tons of greenhouse gases, which is equivalent to 25 billion nuclear explosions. And they're asking, are we pushing Earth out of the Goldilocks zone? Now, the Goldilocks zone is generally considered to be an area where temperatures and water are liquid, and it enables life to exist. And in fact, if the temperature of the Earth gets too hot, then it might actually mean life is difficult to exist. Okay, so as I said earlier, where's all the heat going? Well, most of it has been released and taken up by the oceans. This alone has caused the water to expand. As you heat up water, it expands. Actually, if you freeze it, it also expands. But if you heat it and expands, that raises the sea level. And we have an El Nino coming. El Nino is the increased ocean temperatures. They're already at record highs. And in Peru, what's happened with an El Nino, fishermen noted that at an El Nino, actually they didn't even call it an El Nino, some years they were unable to catch fish because it was too warm. That was simply eventually termed El Nino. And that could mean really disaster for fish and corals. Corals are unable to move. Fish go elsewhere. In addition, people might be unwilling or even unable to deal with extreme temperatures and weather extremes. It is possible that people are leaving Florida due to the climate. Some people are. Now, interestingly enough, I heard an article on the news last night saying that population in Florida has increased because some people are migrating there because it's warmer. So you're going to get migrations in both directions. The question is, what will the extent of that migration be? This is a picture in California of somebody facing a wildfire on top of their house. Okay, something from The Guardian, which is UK magazine, rising seas threaten mass exodus on a biblical scale. And Inside Climate News talking about some areas in the Asian area where you're going to get increased flooding. This is something that came out on May 7th from CNN and BBC News, showing that the highest ever temperature recorded in Vietnam was on May 7th. And it turns out one day later, it was even a little higher than that. 44.2 degrees centigrade is 111.6 degrees Fahrenheit. In addition, there have been high temperatures in Thailand and Myanmar. So this is all around the world, and even recently, even currently, and we're not even into the summer yet. Something on CNN said global temperatures could rise and see where billions of people live where human life doesn't flourish. For example, humans cannot really stand temperatures that high, 111 degrees Fahrenheit, if there's high humidity, because humans cool themselves by evaporative cooling. And if they can't cool because there's so much humidity in the air, it's lethal. And that leads to migration. Now, some examples are New Orleans lost a third of its population after Hurricane Katrina. More than 123,000 Puerto Ricans permanently relocated to the United States after Hurricane Maria a few years ago. There are many parts of Puerto Rico that are still suffering from that. Louisiana has lost 2,000 square miles of land in the last 50 years. And in fact, an HUD, Housing and Urban Development Program, had to resettle a tribal community, which experienced a 98% loss of land since 1955. And there are a variety of disasters driving migrants from Central America to Canada, Costa Rica, Mexico, and the United States. We see that all the time now, and that will only get worse and more intense. So what are the effects of climate change on human health? Well, viruses. Little article from Vaccines work on Pandora virus, basically showing that the melting Arctic is releasing germs and whether we should be worried or not. So microorganisms, viruses and bacteria have been recovered from permafrost dating back 100,000 years. Now, permafrost is the part of the ground that never thaws out, at least until recently. The fact that the climate is warming means the permafrost is beginning to thaw and releasing viruses and bacteria that our immune systems have never encountered before. There was an outbreak of anthrax in 2016 that resulted from thawing permafrost in a really hot summer. Modern antibiotics could probably control bacteria, but maybe not ancient viruses to which we do not have any immunological experience. And the reduction of sea ice means that mineral and oil resources might begin to be exploited. Now, this means, for example, that if there's open pit mining in some areas of the Arctic to get down to minerals and oil resources, they're excavating permafrost that could be hundreds of meters deep, and they could release ancient and totally unknown viruses. We'll have to see. The Scientist magazine is talking about climate change, deforestation, driving bat viruses into humans. It turns out that the bat behavior in Australia has shifted. Climate change and deforestation, bats will spend more time in urban and agricultural settings when food is scarce instead of in the forest where they've been previously. If they're in more contact with humans, and intermediate hosts, they can infect humans. There's something called the Hendra virus, which is really potentially fatal to humans. And in 2006, when a cyclone, which is a Pacific hurricane, destroyed the bat food supply, virus levels surged in the emaciated bats because they couldn't eat enough because of their reduced immune response. And as a consequence, we also see that research has shown that outbreaks follow periods of climatic upheaval like El Nino, which is coming around, where bats establish new roosts nearer to urban food supplies. We know that coronaviruses affect bats, and we know what coronavirus is can cause. We've been dealing with that for the past several years. This is again from the scientists indicating that bat coronaviruses can infect tens of thousands of people yearly, and we know that to be the case. But climate change can work both ways. That is, in some cases, diseases can be worse, but in others, things can be better. A drought may prevent mosquitoes from reproducing, which could be considered a good thing. And diseases transmitted by those mosquitoes would be reduced. There's a mosquito called Aedes albopictus, which is known as the Asian tiger mosquito. And there's a higher risk of it being established in the warmer areas of Europe, Germany, and southern UK with the changes in climate, but less so in southern Europe due to hotter and drier summers. In addition, a drought might make disease from mosquitoes worse because they're primed to reproduce more. And if there's water available, it'll attract many species. And this can be also birds, mammals, mosquitoes, and they'll put them in a local environment where many different pathogens and mosquitoes interact, and that could lead to more human disease. Now, this is not something I expect you to read in any detail, but this is from Nature Climate Change, and it shows on the left a variety of conditions: warming, precipitation, floods, droughts, storms, and so forth, and the type of diseases that are waterborne, vector-borne, so forth, direct contact, and the many diseases that happens. The point of this is that there are many, many diseases out there, and the interaction of the weather and various vectors can cause a lot of diseases, and it's something we have to be aware of. There are many diseases that can be aggravated by climatic hazards. Now, this is again from Nature Climate Change, and it shows in dark blue that there are diseases that are aggravated by climate change. There's some diseases that are diminished or aggravated, and some that are exclusively diminished. The number of diseases that are exclusively diminished are only about 3%. So typically what happens is that climatic hazards and climate change will cause more diseases. And what's happening in the environment? Well, in terms of ocean and marine life, coral bleaching. Corals cannot migrate to escape warming oceans. That leads to a decline in marine fish production because they go to areas where there are corals. Ocean acidification, which is caused by carbon dioxide dissolving in the water. And this causes also the corals to be poisoned. The effect on fisheries. Some ocean species migrate to cooler water. For example, lobsters, okay? And sea level rise is an issue. Lobsters, in fact, go to cooler water, and as do scallops. And lobsters, in addition, go to deeper water where it's cooler. This has caused some problems for the main fishermen who have depended upon lobster fishing as part of their livelihood. Hurricanes. Well, hurricanes here, cyclones in the Pacific. This was the magazine Science talking about the increased U.S. coastal hurricane risk under climate change. And there are shifts in wind patterns that could increase hurricane risk. You saw from the earlier video that the jet stream could cause hurricanes to stall over land and drop enormous amounts of rain. Enhanced ocean warming in the eastern tropical Pacific could shift wind and upper atmospheric wind pattern. El Nino will probably aggravate that as well. Hurricanes could be steered closer to the Gulf Coast and the lower East Coast. As the water gets warmer in the Gulf Stream and Pacific and the Gulf of Mexico, hurricanes will also become more powerful. And in addition, decreased vertical wind shear could allow hurricanes to intensify more. wind shear tends to pull apart hurricanes. If there's less vertical wind shear, then hurricanes will become even stronger and could stall. And they could contain more moisture. Hurricane Harvey in 2017 dumped 54 inches of water in Harris County, Texas. They were not able to handle it. Ice melting. Well, here we see two charts. The one on the left shows Greenland ice mass change, and unfortunately, it's going way down. And the Antarctic ice mass change is also going down pretty much in a straight line. And this is measured from satellite data. The last ice age, it turns out, about 16,000 years ago, showed that in some cases, an ice sheet could retreat up to 2,000 feet a day for a short period of time. And they did this by analyzing how fast the bumps on the ocean floor were based upon the ice going up and down. And this could indicate how fast ice could conceivably melt in Greenland and Antarctica today. Now they have lost more, both areas have lost more than 6.4 trillion tons of ice since the 1990s, and that's continuing. In fact, last year, there was rain in Greenland that had never occurred in human history. Global sea levels rose by about 0.7 inches, which is an enormous amount. And some current glaciers in Antarctica have been measured to retreat as quickly as 160 feet per day. Now, this is a little diagram of how glaciers melt. You can see over here that there's water coming in and melting the glacier from below. The ice is flowing this way, and here's the ice shelf over here, and it basically breaks off icebergs. And this is really an indication that you have melting at the surface, melting underneath, and that causes the ice to break up even more quickly than it had been before. Arctic sea ice has been declining dramatically since 2007 and has not recovered. And this has resulted in a loss of habitat for Arctic creatures. Reindeer, for example, polar bears, muskox, orcas, walruses, and narwhals. In addition, there's a bird called the red knot that is affected because it turns out their breeding habits will now not coincide entirely with the increase in insect populations in the Arctic, and many of them are not unable to find enough food. There's also a decline in the albedo. The albedo is a measure of how much sunlight is reflected back into space. The glaciers and Arctic sea ice are generally white, and they reflect a lot of heat back into space. If that is no longer the case, then the Arctic Ocean, which is darker, absorbs more heat from the sun and increases even more rapidly. And more ice melt delays new ice formation in the autumn. So it's a negative feedback effect, unfortunately. This is from something called Fisorg, and it talks about the Greenland ice sheet is close to a melting point of no return, which is to say that once you get to a certain point of melting, the amount of melt will occur and it will be irreversible. And what is happening with the Greenland ice sheet? Well, research shown that we're halfway to the point after which 6 feet of sea level rise from the melting of Greenland ice will be unstoppable, which is to say, as the ice sheet melts, there is no return because the weather's not getting any warmer. There's been estimated that once over 1,000 gigatons, which is a billion tons of carbon dioxide have been emitted, the southern Greenland ice sheet will melt and raise sea level by almost 6 feet. That will make some areas of the United States uninhabitable, not to mention Europe. And even if no more carbon is emitted, there are self-reinforcing feedback mechanisms that will cause the sea level to rise. It has been estimated that if you have 2,500 gigatons of carbon, the ice sheet would melt completely in Greenland and raise sea level by 22.6 feet, which would be devastating to most countries because many of the population centers are on the coast. Right now, we're at 500 gigatons of carbon emissions released in total. So we're getting into a danger area. Now, there's something called isostatic adjustment that I suspect most people have not heard about. During the last ice age, glaciers were up to 2 miles thick. 2-mile thick ice is extraordinarily heavy, and it caused the Earth's crust to deform simply by weighting it down. If you lay down on a pillow, the pillow goes flat under your head, and what happens is on either side, the pillow rises. The same thing happens with the Earth. The land beyond the perimeter of the glaciers rise, but when the glaciers retreated, the land began to slowly rise again underneath where the glacier was located. On the other hand, the crust outside the perimeter of the glacier started to sink. Now, this takes eons to occur, but it is occurring on the US East Coast and the Great Lake regions. And this means that the land around the Chesapeake Bay will sink as much as a half a foot over the next 100 years because it was on the perimeter of the glacier. And this combined with the rise in ocean temperature, ocean height, will cause more flooding. So we have sinking land and rising seas, and that's not a good combination. Air travel. Well, let's talk about plane turbulence. Altering the jet stream, as we have seen, can lead to more unpredictable clear air turbulence. This is due to wind shear and an unstable jet stream. Wind shear has increased by 15% since 1979. And the greenhouse gas emissions, which trap heat nearest the Earth in the troposphere, really should have been released into the stratosphere. And that leads to a warmer troposphere and a cooler stratosphere. The consequences are hot air is less dense. That means there's less lift for planes. They need a certain amount of density under the wings to lift themselves up. That means they require longer runways to take off, or alternatively, lighter planes. How do you get a lighter plane? Well, you need to remove the cargo or passengers. That's not very comfortable for many people. In addition, a plane engine might reach its maximum operating temperature before producing enough thrust to allow the takeoff if it's much hotter. And extreme heat can lead to overheated brake components and failed air conditioning. And in some cases, we've seen a couple years ago that some runways that were made of asphalt have softened up, and that prevented the planes from even beginning to take off. The unpredictable jet stream, since it's no longer stable going from west to east in a predictable pattern, could mean longer flight times. Typically, planes going from west to east use the jet stream to decrease the amount of time that they're able to travel because they're getting the boost from the jet stream. But if it's unpredictable, then that will increase flight times. In addition, going from east to west typically takes longer because of the jet stream, and unpredictability there is also a problem. So what are some economic impacts about this? Well, Treasury Secretary Yellen said the losses tied to climate change could cascade through the financial system, and that's sort of obvious. Here's something from Reuters showing India's sugar output could fall further because the cane is maturing early before it has enough sugar in it. In addition, there's a crop called cotton that we all know about. Well, cotton plants produce more cotton at the temperature increases up to a certain point. And beyond that point, the amount of cotton they produce decreases. And it's getting to the point in the southern United States and some areas around the world where the temperature is getting too high for the cotton to be able to produce productively. In addition, more insects affect the cotton, and it's causing the need for more pesticides and insecticides. So what are other issues? Well, economic losses, infrastructure damage, losses in property values. I mean, taking out bridges, for example, disruptions in critical services, power, and so forth. Insurers are raising rates and are actually not even going to make any more insurance in high-risk areas like Florida. Supply chain disruption. Well, drought and wildfires are reducing the supply of lumber. Coffee is a problem because Brazil has been affected by a drought. Sushi rice, which many of us like. Most is grown in Florida and has been affected by drought and wildfires. And of course, workplace disruptions prevent workers from even getting to their jobs. Political issues, food, water, energy crisis have undermined some states' capability and legitimacy. And there are more environmentally inhospitable areas and restrictions on resources. There's a higher demand for people smugglers and armed border guards to keep people from being smuggled into countries. And of course, there's climate exacerbated disasters resulting in chaos and injustice. And a lot of people are angry for people and politicians who they feel are responsible for climate change. Now, this is an interesting little factor showing non-state actors and basically showing what's happening around the world, essentially a graphic of what I just said. So where do we go from here? Have a lot of problems. There are a lot of climate doomers. Before there were climate deniers, but now they're climate doomers saying we're all doomed to extinction. And where did this come from? Well, it turns out there's a British professor who wrote a paper called Deep Adaptation, which urged readers to prepare for the inevitable near-term societal collapse due to climate change. And that was published in 2018. He revised it in 2020. And it turns out that it said the paper really doesn't prove the inevitability of such collapse, but it was just a theoretical possibility. But it was still picked up by a lot of publications. United Nations report focused on increases in global temperature of 1.5 degrees centigrade. And it said would lead to the death of coral reefs and ice-free summers in the Arctic. As I said, ice-free summers in the Arctic have the problem of increasing heat uptake. And supposedly from that report, it says we have 12 years to limit the climate catastrophe. Well, the report never stated that. It was taken from a sensationalist headline in The Guardian right here. And that turns out not to be the case. There really is no tipping point. The report said we have 12 years to cut the global emissions in half to stay consistent with a 1.5 degrees Celsius scenario. That wouldn't be a threshold, but the point simply saying as the temperature increases, we get more bad impacts. So bad impacts are higher at 2 degrees than they were at 1.5 degrees. That is, the more the temperature rises, the higher the risk of impacts on the environment and the planet. So climate change is not really pass-fail. There are feedback loops that come to rise. Melting permafrost leads to more carbon release and methane release into the atmosphere. But the feedback loops are really dwarfed by the fact that we're burning fossil fuel at an enormous rate. Okay, and the world cannot avoid the effects of warming, but there's also not a level which we're doomed. We might be able to make some accommodation. If net zero emissions were released, then we would probably be able to adapt. If we continue to burn fossil fuels and the temperature rises, then there could be increased problems. So what are some mitigation strategies? Well, there's carbon dioxide removal, and that's becoming a really hot topic now, pardon the pun. Is carbon dioxide a viable option? Well, in 2022, the world emitted 40.5 billion tons. That's 4.5 gigatons of carbon dioxide in 1 year. And so if everybody on Earth planted a tree, 8 billion trees, and that would go back 43 hours based upon that 1 year equals 40.5 gigatons once the trees had matured, which takes a while. Okay, direct air capture technology, which is being tested out, could in theory remove 1 million tons per year per facility. So 1 million tons versus a gigaton, frankly, isn't very much, and it only means 13 minutes would be saved. There are laboratory techniques to remove CO2, but they might not work in the real world. And as a point of fact, we have never removed atmospheric pollutant like that on a global scale. So, as I mentioned earlier, chlorofluorocarbons only work by removing the source and letting nature do the cleanup, but that could take thousands of years. There was a watchdog group that said basically the carbon capture hype is being done by the fossil fuel industry as a way to make them less amenable to moving off of oil and gas. Now, there was a carbon capture project in Norway that had been halted in April by high cost. It was originally expected to capture 400,000 tons of carbon dioxide a year, and it was commissioned to be in 2026. It has stopped. They're working on it, so we'll see what happens. Hydrogen economy. everybody's asking whether hydrogen will be a better fuel. And hydrogen currently comes from fossil fuels, and it means releasing more carbon dioxide into the atmosphere to produce that hydrogen. Electrolysis produces hydrogen from water with no pollutants, and you can do that in a green way by using solar power. In fact, there are also natural hydrogen mines that are being discovered where you can just mine hydrogen from the earth. But the question is whether it's good for heating. And it's really not that good because it's a low energy content and it's really too flammable. It's also difficult to store and transport. Long-term storage requires liquefaction, and there are problems with the vessels that are containing the liquid hydrogen. Hydrogen also leaks out very easily and reacts with the hydroxy radical in the atmosphere, which then eliminates methane and ozone. But if you have too much hydrogen, the methane would stay in the atmosphere longer. Geoengineering, pretty far out, really science fiction. It means reducing the amount of solar radiation hitting the planet. People are talking about spraying aerosols into the atmosphere, and they get this from the fact that some volcanoes emit large amounts of sulfates into the atmosphere, and that turns out to reduce the atmospheric ability to absorb heat. To do that by human intervention is very controversial and may not be quick and might have to be maintained for hundreds of years. Sulfur dioxide aerosols would also produce acid rain and increase ozone depletion. Some scientists have proposed to put moon dust into the Earth's orbit. That's a great idea, but how would you get 54 million metric tons a year into the outer space? How would you do that? You'd have to have a base on the moon and figure out a way to take the moon dust and put it into the air. Some people have said putting a space umbrella between the sun and the earth might work. Well, the poles might not be cooled as much as the tropics, and then how do you actually do that? Saving the glaciers are melting. They've lost 60% of their volume in Switzerland since 1950, 6% alone last year. In the Andes, they're whitewashing rocks to reflect sunlight. Some Swiss ski resorts are spreading white blankets across ski slopes, but it's not really feasible to use on entire glaciers. Nuclear is one possibility, but is that emissions free? Well, we have the carbon from uranium extraction, transportation, and processing producing its own emissions, and construction and demolition to produce these plants releases CO2. In addition, nuclear waste has to be stored for thousands of years under strict conditions. Nobody in the United States really wants nuclear waste stored in their states anymore. It's better than some sources of electricity, but not as good as others. Thorium reactors are more efficient than uranium fission reactors, but they're not happening very much. Nuclear will probably be a part of the mix along with the wind, solar, and hydro. This is a little example of where you're getting energy from. Brown coal is probably the worst in terms of producing CO2. The best is hydropower and photovoltaic. If we have a mix of these, that will be helpful. Other future possibilities include space-based solar power, nuclear fusion, but the earliest fusion plant might be 30 years away. There's something called an ultra-white paint that reflects 98% of sunlight away and may replace air conditioning. It sends infrared radiation away from the surface into outer space. And if painted on a roof, it could have a cooling power equivalent to many central air conditioning units. So I guess I want to know, have you taken any personal actions to help alleviate climate change? I personally put on all LED bulbs in my house. I have solar panels. I typically keep my cars as long as possible. That's some of the responses. So what can we be done? Okay, I think acknowledging the problem is the first step. Adopting multiple strategies, renewable power sources, conservation, carbon capture, which may become much more efficient, alternative transportation. There's a lot of talk about electric vehicles. They have their own problems. That's a discussion for another presentation. Fuel efficient vehicles, less airline travel. But the most important thing is to cut emissions by stopping and slowing the use of fossil fuels. I hope that this can be accomplished in time. And I want to thank you for your attention. Art, I'm going to turn it back over to you.
Okay, Steve, thank you so much. I gotta say it's and be interested in hearing other people's questions and comments, but that is definitely the most comprehensive, extensive, thorough reporting on the situation with the climate that I have seen in one place at one time. And I know it's based on years of research that you've done, and I congratulate you and thank you for doing all of that. And for a while there, I was wondering if we'd have to open up a hotline because you painted a pretty scary picture. But then you gave us sort of an aspirin at the end that there is, there are things we can do. But you did mention in a broad sense, solutions like, changing transportation systems and whatnot, but kind of a broad sense. So you've shown us a whole host of things that are happening in the climate, and then a list, a kind of a large selection of things that we can do. But where do we start? I know you start with raising awareness. I think people are pretty much aware of it. But in terms of taking an action, it gets overwhelming when you say, okay, we can't take on the whole enchilada at once. So do you have any thoughts as to, and you mentioned starting small, putting LEDs in your house and that sort of thing. We've done that. I'm sure many of us have done that. What would you suggest as being good places to start, just to get, to take us to the next step? We've done some small steps. We can't take on the whole enchilada, I don't think. What would be the next some logical alternatives for us to go as next steps?
Well, I think there has to be an economic incentive. There has to be a political will to be able to take the hard steps that we need to do. I mean, cutting down on fossil fuels is really the best way to solve the problem, or at least slow down the problem. Okay, if we can slow it down, that'll give us more time to think of other solutions. I mean, we each take our own personal steps, but the United States is only one country. And there are other countries where they're not even bothering to try this. I mean, China, for example, is still continuing to build enormous numbers of coal-powered power plants, which are adding to pollution. And we saw what happened at the last Olympics, where they basically had to stop all manufacturing for weeks beforehand to clear up the pollution in Beijing. And so there has to be somehow an international will to do this. Now, economy tends to drive these things. And so if we figure out some way to have an economic incentive for this. The problem, of course, that there are many countries where the people, frankly, are poor. And climate change and cutting down the use of fossil fuels is not in their personal best interest. So the United Nations—
Although it's, if I may interrupt, although it's sad, the poorer, less developed countries are most impacted by climate change, exactly. Right? But as you said, yeah, so it's a catch-22.
It is a catch-22. So, I mean, places like India, really, it's pretty much the most populous country on earth, is having major problems, will have major problems. I mean, there are parts of Pakistan that, as the ocean rises, will be inundated by floods. And so we have to figure out a way, and I'm not sure how to do this, quite frankly. We have to figure out a way to incentivize people on a global scale to stop burning more fuels. At the moment, that's the only way to reduce it, okay? All these other steps, carbon capture, solar power, will help, but that's not the major determining factor in all these.
And getting back to our theme, I think central to that is leadership, right? Everything rises and falls on leadership, right?
Leadership, and that's really the point of all this. Our leaders need to acknowledge this and step up to the plate, as it were, and figure out ways, now that they know what the problem is, to solve it. And unfortunately, there's a lot of vested self-interest, shall we say. The oil and gas companies are talking a lot about carbon capture, but they're trying to still keep pumping oil and gas from the earth and burning it. And it's difficult. I wish I had a solution, Art.
Yeah, Annie Green, you raised your hand. Go ahead, Annie, unmute yourself.
Hey, Steve, just a question. ESG right now is in the forefront of the leaders, so to speak, environmental, social, and governance, and leading into even in ESG investing. How do you think that's going to help with this, and do you think that it'll be timely enough? Because I'm not certain of how it's moving or what direction it's moving in, but I know that there's a lot of generation around it, and I know that there's quite a few groups who are now coming on board of an ESG framework.
It's going to help, but I just don't know, frankly, if it's going to be soon enough. I mean, we're on a path where the average global temperature is continuing to rise. And I mean, Art and other people said, could you make sure you're a little more optimistic in your presentations? But that's very difficult, quite frankly. It is very difficult to do that.
No, I agree, and I don't think you should be. I think people need to see the truth, and if that doesn't hit them, then we got a problem.
Well, we have a problem currently, yes. So.
Yeah. It's
anybody else? Yeah, anybody else? We've got some good brains here online. Before we close out, anybody, any last thoughts from anybody in our audience? Feel free to unmute yourself and just shout out.
Steve, I think this is good. I always like seeing your work because it brings home reality, and I think it's something that we need to be aware of. And I think it's something that needs to impact the masses, but I don't think enough people are aware of the total impact of what would happen with the environment, how it would affect the way we live, work, and play.
Yeah.
Hey, Art, I might offer a dramatic thing. In the end, we could probably try to reduce population, purposely make contraceptives and any possible democratic or autocratic approach to drive populations down as fast as possible by making it a internationally wrong thing to be doing is to increase population anywhere. But of course, you'd have to take the economic cuts, and nobody with any money is going to support that, because anybody who runs the world doesn't want to see less people. They just as soon have more people to buy stuff. So you'd have to be able to get some kind of international agreement that we just have to drive down people and drive up plant life. But who's going to make that decision?
Exactly right. That's the problem.
Yeah. Especially when you make it without thinking, like when they reduced in certain areas that you could only have one kid. And when you have people that want a son instead of a daughter, and they decide to kill off girl babies so that they can have a son. There's a lot around that when you're reducing populations that you need to think of the mentality and also the morality of the people that you're asking to do that.
Absolutely.
And they actually changed that, Annie, because now it turns out they had a decreased population, and they want more people.
I know.
But they want more customers.
Yeah. So I just think.
Yeah, Candace has a good, go ahead, Andy, but then Candace has a comment.
No, let Candace go, because I've already gone. Go ahead.
Thanks very much. I was just thinking about working in communications and advertising over the years, how you've had to adapt messaging and adverts to try and speak to people at different times. And I was thinking, if our communications and messaging are not working, they really need to be rethought in order for us to speak to the masses and actually really have impact.
Absolutely,
so as a communicator, I always wonder how we can rethink that and really help sort of some of the content of what's being spoken about today to be really effective and to be met by the right audiences.
Well, some of the environmental groups are pushing it, but I mean, they're somewhat effective, but not totally clear how effective that will be.
Right? Yeah, thanks.
Sure.
Steve Newman here with a comment. Hang on one sec. Yeah, I did actually have some experience directly working on climate issues when I was chief environmental engineer at NASA. And we did a lot of work with UNEP, which is the United Nations Environmental something program. And we work with them to phase out CFCs in the space shuttle production manufacturing activities. I actually took a group of 35 members of UNEP to Thiokol out in Utah to observe how we were gradually phasing out ozone depleting substances in the manufacturing of solid rocket motors on the shuttle. And there was a tremendous amount of collaboration between the State Department, EPA, and UNEP. And it really impressed me as from the standpoint of leadership, really ultimately beyond doing things on a personal level, there does need to be that kind of collaboration. And I think Steve Hausman is really framed very well the fact that the solution has got to be a globally cooperative effort. And I think certainly UNEP and the other groups within the UN umbrella will certainly be a very specific leadership will have to play a very prominent leadership role in addressing the issues of climate change. So,
Yeah.
but very nice presentation. Really enjoyed the breadth and depth of it.
Thank you,
The
Zeke.
only other comment that I'd make is that all of these challenges, every single one of these challenges has a flip side in terms of people coming up with solutions, people coming up with innovations. And I think to put a more positive spin on it, yeah, I mean, a lot of change has got to take place. And I think it really will stimulate thinking and technological innovation. So yeah, and folks along the coast may have to move their beach house back, but at the same time, there will be new jobs created. There will be new the society and technology has enough flexibility, in my opinion, to rise up to many, many, many of these challenges. And somehow I think we're going to be able to muddle through. So
I mean,
that's all I had.
I mean, I agree with you, Steve. I think humans want to do the right thing, but they have to be shown what the right thing is. And one thing that I didn't discuss, and who knows what's going to happen in the future, but we're dealing with a lot of new artificial intelligence tools. And there may be things that come along that we can't anticipate and might help us out in regard to climate change. So stay tuned.
Oh, what a
Will
great
do.
ending. Like that. We're a little past the hour now. So, you want me to?
Oh, yeah, but before I close it and turn over to Andy to close out, next week, I encourage everybody to please spread the word. Hope to see all of you back here next week, same time, same place. We'll be in our second session of our 6 sessions of leadership styles. talking about foresight-based leadership. We've set the foundation here with Steve giving us the science-based leadership flavor. Now the next thing is, how do you look ahead? Because this stuff does definitely impact, as Steve mentioned, not just the short term, but way out. It could be centuries out, and that requires a foresight-based flavor of leadership, and that's what Annie is going to present to us next week. So you definitely don't want to miss that, and I encourage you to spread the word. So with that, Annie, I'll turn it over to you for your final thoughts.
Well, final thoughts. I just want to thank everybody for coming. And, our constant follower, Candace, thank you so much for always being there for us. Again, share this. We know that it's difficult. Sometimes people forget or, they remember the last moment or something comes up, but we are recording this as well. So we want to also get these out. So we will be sharing the same, these conversations and stuff through a YouTube channel as well. So when you get that, share it with everyone else, send it out, let's spark some interest and get some engagement in this, because I think these are some really good topics. And I think they're topics that need to be said. They're discussions that need to be had. And I think that, the more people that actually get to hear them, whether it be in person with us or on the YouTube channel, that it'll help us to generate more and more interest in what we're saying. So with that, I thank you again for being here. And I'm sorry I'm not on video today, but I am traveling. But I definitely couldn't miss Steve's presentation because I'm just so in awe of, the work that he does.
Thank you.
Have a great day, you all. Okay.
Bye.
Thanks.